Okay, hi everyone, welcome back to this video series on Windows Server 2012. Okay, understanding features on demand. One of the problems in previous versions of Windows Server was how roles and features were stored on the hard disk. Before the introduction of Windows Server 2012, even if a server role or feature was disabled on a server, the binary files for that role or feature were still present on the disk. The problem with this approach is that even if you disable the role, it still consumes space on your hard drive. Features on demand in Windows Server 2008 R2 solves this issue because not only can administrators disable a role or feature, they can also completely remove the role or features files. Once this is done, the state of removed is shown in Server Manager, or the state of disabled with payload removed is shown in the dism.exe utility. To reinstall a role or feature that has been completely removed, you must have access to the installation files. If you want to remove a role or feature completely from the system, use remove with the uninstall Windows feature cmd-let of Windows PowerShell. For example, if you want to remove Windows Explorer, Internet Explorer, and all dependent tired components completely, run the following Windows PowerShell command: uninstall Windows feature server GUI shell remove. If you want to reinstall a role or feature that has been removed completely, use the Windows PowerShell source option of the install Windows feature server manager cmd-let using the -source option states the path where the WIM image files and the index number of the image will be located. If an administrator decides not to use the -source option, Windows will use Windows Update by default when you're using the feature on demand configuration. If feature files are not available on the server computer and the installation requires those feature files, Windows Server 2012 R2 can be directed to get those files from a side-by-side feature store, which is a shared folder that contains feature files. It is available to the server on the network from Windows Update or from installation media. This can be overwritten using the source option in the Windows PowerShell utility to install a removed role or feature using a WIM image. Follow these steps. 1. Run the following command: get Windows image path /install.wim. In step 1, image path is the path where the WIM files are located to. Run the following command: install Windows feature name source win path : index. In step 2, feature name is the name of the role or the feature from get Windows feature, and path is the path to the WIM mount point, and index is the index of the server image from step 1. To add or remove a role or feature, you must have administrative rights to the Windows Server 2012 R2 machine. Storage in Windows Server 2012 R2. As an IT administrator, you'll need to ask many questions before you start setting up a server. What type of disks should be used? What type of RAID sets should be made? What type of hardware platform should be purchased? These are all questions you must ask when planning for storage in Windows Server 2012 R2. In the following questions, I will answer these questions so you can make the best decisions for the storage in your network's environment. Initializing disks. To begin, I must first discuss how to add disk drives to a server. Once a disk drive has been physically installed, it must be initiated by selecting the boot partition. Different types of partition styles are used to initiate disks: master boot record, MBR, and GUID partition table, GPT. MBR has a partition table that indicates where the partitions are located on the disk drive, and with this particular partition style, only volumes up to 2 terabyte, 2.42048 GB are supported. An MBR drive can have up to 4 primary partitions, or can have 3 primary partitions and 1 extended partition that can be divided into unlimited logical drives. Windows Server 2012 R2 can only boot off an MBR disk unless it is based on the Extensible Firmware Interface EFI. Then it can boot from GPT. An Itanium server is an example of an EFI-based system. GPT is not constrained by the same limitations as MBR. In fact, a GPT disk drive can support volumes up to 18 EB, 368 million terabytes, and 128 partitions. As a result, GPT is recommended for disks larger than 2 terabytes. For disks used on Itanium-based systems, exercise 1.3 demonstrates the process of initializing additional disk drives to an active computer running Windows Server 2012 R2. If you're not adding a new drive, then stop after step 4. I am completing this exercise using computer management, but you also can do this exercise using Server Manager. Configuring basic and dynamic disks. Windows Server 2012 R2 supports 2 types of disk configurations: basic and dynamic. Basic disks are divided into partitions and can be used with previous versions of Windows. Dynamic disks are divided into volumes and can be used with Windows 2000 Server and newer releases. When a disk is initialized, it is automatically created as a basic disk, but when a new fault-tolerant RAID volume set is created, the disks in the set are converted to dynamic disks. Fault tolerance features and the ability to modify disks without having to reboot the server are what distinguish dynamic disks from basic disks. The following are the actions that can be performed on a disk: formatting partitions, making partitions as active, creating and deleting primary and extended partitions, creating and deleting logical drives, converting from a basic disk to a dynamic disk. The following actions can be performed on dynamic disks: creating and deleting simple, striped, spanned, mirrored, or RAID 5 volumes, removing or breaking a mirrored volume, extending a simple or spanned volumes, repairing mirrored or RAID 5 volumes, converting a dynamic disk to a basic disk after deleting all volumes. In exercise 1.4, you'll convert a basic disk to a dynamic disk. Converting a basic disk to a dynamic disk. 1. Open Computer Management under Administrative Tools. 2. Select Disk Management. 3. Right-click a basic disk that you want to convert and select Convert to Dynamic Disk. 4. The Convert to Dynamic Disk dialog box appears. From here, select all of the disks that you want to convert to dynamic disks. In this exercise, only one disk will be converted. 5. Click OK. 6. The Convert to Dynamic Disk dialog box changes to the Disks to Convert dialog box as and shows the disks that will be converted to dynamic disks. 7. Click Convert 8. Disk management will warn that if you convert the disk to dynamic, you will not be able to start the installed operating system from any volume on the disk except the current boot volume. Click Yes. 9. Close computer management. The converted disk will now show as dynamic in disk management, managing volumes. A volume set is created from volumes and span multiple drives by using the free space from those drives to construct what will appear to be a single drive. The following list includes the various types of volume sets and their definitions. Simple volume uses only one disk or a portion of a disk. Spanned volume is a simple volume that spans multiple disks with a maximum of 32. Use a spanned volume if the volume needs are too great for a single disk. Striped volume stores data in stripes across 2 or more disks. A striped volume gives you fast access to data but is not fault tolerant, nor can it be extended or mirrored. If one disk in the stripe set fails, the entire volume fails. Mirrored volume duplicates data across 2 disks. This type of volume is fault tolerant because if one drive fails, the data on the other disk is unaffected. RAID 5 volume stores data in stripes across 3 or more disks. This type of volume is fault tolerant because if a drive fails, the data can be recreated from the parity of the remaining disk drives. Operating system files and boot files cannot reside on the RAID 5 disks. Exercise 1.5 illustrates the procedure of creating a volume set. Creating a volume set. 1. Open computer management under administrative tools. 2. Select disk management. 3. Select and right-click a disk that has unallocated space if there are no disk drives available for a particular set. That volume set will be grayed out as a selectable option. In this exercise, you'll choose a spanned volume set, but the process after the volume set selection is the same regardless of which kind you choose. The only thing that differs is the number of disk drives chosen. 4. The welcome page of the new spanned volume wizard appears and explains the type of volume set chosen. Click Next. 5. The select disk page appears. Select the disk that will be included with the volume set and click Add. Repeat this process until all of the desired disks have been added. Click Next. 6. The assign drive letter or path page appears. From here, you can select the desired drive letter for the volume. Mount the volume in an empty NTFS folder or choose not to assign a drive letter. The new volume is labeled as E. Click Next. 7. The format volume page appears. Choose to format the new volume. Click Next. 8. Click Finish. 9. If the disks have not been converted due to dynamic, you'll be asked to convert the disks. Click Yes. The new volume will appear as a healthy, spanned dynamic volume with the new available disk space of the new volume set. Storage spaces in Windows Server 2012 R2. Windows Server 2012 R2 includes a technology called storage spaces. Windows Server 2012 R2 allows an administrator to virtualize storage by grouping disks into storage pools. These storage pools can be turned into virtual disks called storage spaces. The storage spaces technology allows an administrator to have a highly available, scalable, low cost and flexible solution for both physical and virtual installation. Storage spaces allows you to set up this advantage to either a single server or in scalable multi-mode mode. So before going any further, let's take a look at these two terms that you must understand. Storage pools are a group of physical disks that allows an administrator to delegate administration, expand disk sizes, and group disks together. Storage spaces allows administrator to take free space from storage pools and create virtual disks called storage spaces. Storage spaces gives administrators the ability to have precise control, resiliency, and storage tiers. Storage spaces and storage pools can be managed by an administrator through the use of the Windows Storage Management API Server Manager or Windows PowerShell. One of the advantages of using the storage spaces technology is the ability to set up resiliency. There are three types of storage space resiliency: mirror, parity, or simple no resiliency. Now that you understand, now that you understand what storage spaces and storage pools do, let's take a look at some of the other advantages of using these features in Windows Server 2012 or 2 availability. One advantage to the storage spaces technology is the ability to fully integrate the storage space with failover clustering. This advantage allows administrators to achieve service deployments that are continuously available. Administrators have the ability to set up storage pools to be clustered across multiple nodes within a single cluster. Tiered storage. The storage spaces technology allows virtual disks to be created with a two-tier storage setup. For data that is used often, you have an SSD tier. For data that is not used often, you use an HDD tier. The storage spaces technology will automatically transfer data to a sub-file level between the two different tiers based on how often the data is used. Because of tiered storage, performance is greatly increased for data that is used most often, and data that is not used often still gets the advantage of being stored in on a low-cost storage option. Delegation. One advantage of using storage pools is that administrators have the ability to control access by using access control lists, ACLs. What is nice about this advantage is that each storage pool can have its own unique access control list. Storage pools are fully integrated with Active Directory domain services, redundant array of independent disks. The ability to support drive sets and arrays using redundant array of independent disk RAID technology is built into Windows Server 2012 or 2. RAID can be used to enhance data performance, or it can be used to provide fault tolerance to maintain data integrity in case of a hard disk failure. Windows Server 2012 or 2 supports three types of RAID technologies: RAID 0, RAID 1, and RAID 5. RAID 0, disk striping. Disk striping is using two or more volumes on independent disks created as a single striped set. There can be a maximum of 32 disks. In a striped set, data is divided into blocks that are distributed sequentially across all of the drives in the set. With RAID 0 disk striping, you get very fast read and write performance because multiple blocks of data can be accessed from multiple drives simultaneously. However, RAID 0 does not offer the ability to maintain data integrity during a single disk failure. In other words, RAID 0 is not fault tolerant. A single disk event will cause the entire striped set to be lost, and it will have to be recreated through some type of recovery process, such as tape backup. RAID 1 disk mirroring. Disk mirroring is two logical volumes and two separate identical disks created as a duplicate disk set. Data is written on two disks at the same time. That way, in the event of a disk failure, data integrity is maintained and available, although this fault tolerance gives administrators data redundancy. It comes with a price because it diminishes the amount of available stored space by half. For example, if an administrator wants to create a 300 gig mirrored set, they would have to install two 300 gig hard drives into the server, thus doubling the cost for the same available space. RAID 5 volume disk striping with parity. With RAID 5 volume, you have the ability to use a minimum of 3 disks and a maximum of 32 disks. RAID 5 volumes allow data to be striped across all of the disks with an additional block of error correction called parity. Parity is used to reconstruct the data in the event of a disk failure. RAID 5 has slower write performance than other RAID types because the OS must calculate the parity information for each stripe that is written, but the read performance is equivalent to a stripe set. RAID 0, because the parity information is not read. Like RAID 1, RAID 5 comes with additional cost considerations. For every RAID 5 set, roughly, an entire hard disk is consumed for storing the parity information. For example, a minimum RAID 5 set requires 3 hard disks, and if those disks are 300 gig each, approximately 600 gig of disk space is available to the OS, and 300 gig is consumed by parity information, which equates to 33.3% of the available disk space. Similarly, in a disk 5 RAID set of 300 gig disks, approximately 200 gig of disk space is available to the OS, which means that 20% of the total available space is consumed by the parity information. The words roughly and approximately are used when calculating disk space. A 300 gig disk will really be only about 279 gig of space. This is because vendors define a gigabyte as 1 billion bytes, but the OS defines it as 2030-1073-741824 bytes. Also remember that file systems and volume managers have overhead as well. Table 1.4 breaks down the various aspects of supported RAID types in Windows Server 2012. RAID level, RAID type, fault tolerance advantages, minimum number of disks, maximum number of disks. 0, disk striping, no, fast read and writes. 2, 32. 1, disk mirroring, yes, data redundancy and faster writes than RAID 5. 2, 2. 5, disk striping with parity, yes, data redundancy with less overhead and faster reads than RAID 1, 2, 32. Creating RAID sets. Now that you understand the concept of RAID and how to use it, you can look at the creation of RAID sets in Windows Server 2012 or 2. The process of creating a RAID set is the same as the process for creating a simple or spanned volume set, except for the minimum disk requirements associated with each RAID type. Creating a mirrored volume set is basically the same as creating a volume set as shown in exercise 1.6, except that you will select new mirrored volume. It is after the disk select wizard appears that you'll begin to see the difference. Since a new mirrored volume is being created, the new volume requires 2 disks. During the disk select process. If only one disk is selected, the next button will be unavailable because of disk management. The disk minimum has not been met. Refer to figure 1.3 to view the selected disks page of the new mirrored volume during the creation of new mirrored volumes, and notice the next button is not available. To complete the process, you must select the second disk by highlighting the appropriate disk and adding it to the volume set. Once the second disk has been added, the Add button becomes unavailable and the next button is available to complete the mirrored volume set creation. See figure 1.4. After you click next, the creation of the mirrored volume is set again, just like the rest of the steps in exercise 1.5. A drive letter will have to be assigned and the volume will need to be formatted. The new mirrored volume set will appear in disk management in figure 1.5. Notice that the capacity of the volume equals 1 disk, even though 2 disks have been selected. To create a RAID 5 volume set, you use the same process that you used to create a mirrored volume set. The only difference is that a RAID 5 volume set requires that a minimum number of 3 disks be selected to complete the volume creation. This process is simple. Select new RAID 5 volume, select the 3 disks that will be used in the volume set, assign a new letter and format the volume. Figure 1.6 shows a newly created RAID 5 volume set in disk management. Mount points. With the ever-increasing demand for storage, mount points are used to surpass the limitation of 26 drive letters and to join 2 volumes into a folder on a separate physical disk drive. A mount point allows you to configure a volume to be accessed from a folder on another existing disk. Through disk management, a mount point folder can be assigned to a drive instead of using a drive letter, and it can be used on a basic or dynamic volumes that are formatted with NTFS. However, mount point folders can be created only on empty folders within a volume. Additionally, mount point folder paths cannot be modified. They can be removed only once they have been created. Exercise 1.6 shows the steps to create a mount point. Creating a mount point. 1. Open Server Manager. 2. Click, then expand storage space. 3. Select disk management. 4. Right-click the volume where the mount point folder will be assigned and select change drive letter and paths. 5. Click add. 6. Either type the path to an empty folder on an NTFS volume or click browse to select or make a new folder for the mount point. So I'm going to adhere today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.